talked about, it's going to be very, very relevant here when we talk about what we plan for in the future and how that informs uh, planning for maybe new infrastructure or changes in operations. So next slide, Steve. All right, so we've spent some time. This is what you're seeing here is a summary of decades worth of research by the U.S. Bureau of Reclamation, by University of Arizona, by ASU, with SRP, collaborating with all those institutions. And the bottom line is we've developed 1,000 projections of future Salt Verde stream flow. And there's three steps to this. And you can't just take weather or climate model output and jam that into a physical hydrology model just yet and get something that makes sense to plan for. Usually that leaves you with really, really biased outcomes and you can't really make sense of it and plan for it. But this strategy here gives you an unbiased baseline and adjustments to that baseline for climate change, and also includes natural variability. So I'll talk about natural variability first. You can see there in the upper left-hand corner, the proxy stream flow record from tree rings that Steve talked about. That goes back to the mid 1300s. And you can see that there's all sorts of droughts and pluvials in there. And by analyzing the sequencing of droughts and pluvials and the probability of shifting from a wet regime to a dry regime, you can stochastically generate future plausible stream flow sequences. So step one was to develop 1,000, actually they're about 109-year projections of stream flow based on just natural variability alone through stochastically generating it there, leveraging the tree ring record. Then step two is looking at what the global climate models project for the Salt and the Verde watersheds. And what you're seeing here in that scatter plot is there's a lot of range in what's possible from climate change. A large range in warming. Every projection suggests warming, but there's a lot of variability in how winter precipitation is going to change in the future, with plenty of projections saying wetter winters and plenty of projections saying drier winters. But we basically leverage what's in the climate model projections by coming up with a warming number, a delta T, and then also analyze how precipitation is expected to change with the climate model projections. And then there's a statistical hydrology model that relates changes in temperature and precipitation to changes in stream flow. So you take the 1,000 stream flow projections and feed the changes in temperature and precipitation that you get from the climate models, feed that into a statistical hydrology model to adjust the projections for climate change over the next century. And that's really helpful because you get a wide range of plausible futures that account for both natural variability and climate change. So next slide, Steve. So what I'm showing here is definitely a lot on these graphics. I'm going to give you the take-home messages. I wanted to put these graphics up here to show you how much went into this and that we did our homework. But what you're seeing here is just what the climate change impacts due to Salt Verde stream flow for the 1,000 projections that I talked about. So once you adjust those 1,000 projections for climate change, what happens? The fact that there's a lot of brown and much less green, especially to the left of that zero contour, means that most years, most percentiles, stream flow is declined due to the climate change adjustments. But to the right of that zero contour, there's some pretty notable increases in stream flow. And so why are there declines from climate change? And why are there increases from stream flow from climate change for the wetter years? First, the declines. The declines are because broadly in a warmer world, you expect more evaporative losses from the landscape, and that takes a bite out of the runoff budget Also, the global climate models suggest a slight decrease in average precipitation, although highly uncertain. Um, Perhaps a little more certain than that, though, the global climate models project wet winters to get wetter. And the reason why there's a little more confidence in that in the climate modeling community is because a hotter uh, global atmosphere has hotter global oceans. Those evaporate at a greater rate, and therefore there's more water vapor in the atmosphere in a warmer world. So when you do get storms, they tend to produce more precipitation. So that's why the extreme wet ends get wetter. And that's why, by and large, you see increased variability in stream flow from climate change in front of you here, and a slight decrease in average stream flow. But the decrease in average stream flow is only around 2.5% to 5%. So let's keep that in mind, that relatively small decrease in average stream flow that you're seeing in front of you, about 2.5% to 5%. That we're projecting on the Salt and the Verde, because I'm going to talk about the Colorado River in a few slides from now. Next slide, Steve. Is it advancing? There we go. So this is another way to look at the 1,000 projections. Instead of comparing the projections to themselves when they've been climate change adjusted, I'm just comparing the full climate change adjusted projections, all 1,000 of them, to the 100 years we just experienced. And the interesting thing here is, since the 100 years we just experienced has a 28-year drought at the end of it, um, the odds are stacked from a natural variability perspective for projections in the next 100 years to be wetter than the last 100 years. So that's why you're seeing average stream flow. The dashed line is to the right of the zero contour, um, more often than not here. So there's actually, from a natural variability perspective, the expectations of slightly increased average stream flow, even though climate change adjustments decrease average stream flow. So both natural variability and climate change are important to consider in the future. And you could see, based on the stretch of the color bars here, what we model is a wide range of future plausible projections: extremely wet centuries and extremely dry centuries, centuries that are very pluvial dominated, where you have many consecutive years of wet winters, for instance, and then centuries that are very drought dominated, where you never get impressive pluvials and you have long droughts, and everything in between we're modeling. Next slide. Sorry for the delay here. I'll try to give a little more lead time for the slide transition.
Is it not shown up yet?
Not yet. Here we go. All right. So climate change impacts on stream flow. I said that only 2.5% to 5% decrease in average stream flow is what we're uh, planning for on the Salt and the Verde River reservoirs. And if we were all in a room together, I would ask, does that sound like a big or small number compared to what you often hear about the Western United States future under climate change? And I would expect people to think that sounds like a small number. Maybe you don't, but that's usually what the message is that the impacts of climate change on stream flow are going to be a lot more than that. But really what that's referring to, it's very Colorado River focused, that message. And the Colorado River is much more sensitive to warming than the Salt and the Verde River stream flow. And this surprises some people, and hydrologic research over the last several years has uncovered this. And broadly, the reason why there's this low sensitivity to temperature on the Salt and the Verde rivers is because the stream flow occurs not just from snowmelt in the late winter and early summer. Actually, there's very little snowmelt in the early summer or late spring on the Salt and the Verde. The stream flow is generated in the middle of winter with rain events or winter snowmelt, and then some early spring snowmelt. So the stream flow is being generated during a time when the sun is low and the days are short. There's a limit to evaporative losses from the landscape. And it's really the opposite situation on the Colorado River, where the snowpack develops, peaks in April, and then it melts through May and early June. And that's a time of year when plants are going to be growing. And if you warm that situation, there's a bigger bite out of the runoff budget. And that's why the Colorado River is more sensitive to warming, actually potentially 5 times more sensitive to warming. Next slide. So this next slide here is more of a deeper dive into what's actually going on. The previous slide was more of a high level, kind of maybe tying several different hypotheses together, but this is specifically with a physical hydrology model, uncovering why there's this low sensitivity to warming on the Salt and the Verde rivers. What you're seeing here is the take-home message is that if you warm Arizona's watersheds, if you warm it by a little bit, maybe 1 to 2 degrees Celsius, you actually get more stream flow in certain cases, in this case on the Beaver Creek. So warming equals more stream flow, slight warming. Why would that be? Well, it's because you take winter storms that would have otherwise deposited a lot of snow on the watershed, and that snow is sitting up there sublimating. If it's portion of its rainfall instead of snowfall, then that more easily generates into stream flow and refills the reservoir rather than sitting up on the watershed sublimating. So for a little bit of warming, the decrease in sublimation overcomes the increase in transpiration. But if you get to warming above 2 degrees Celsius, then the increase in evapotranspiration starts to overcome the decrease in snow sublimation. And that's where you start to have decreased stream flow. But this is pointing to snow sublimation being a key buffer to why the Salt and the Verde is less sensitive to warming than the Colorado River. This is a really exciting study here we did with Arizona State University. Next slide. So talked about how we've used 1,000 projections of future stream flow. They are very, very wet centuries in there, very, very dry centuries, slight decrease in average stream flow we're planning for, but a wide range of possibilities that are plausible. And what you could do is you can put these inflow projections into a reservoir planning model and come up with a distribution of important reservoir system metrics. And that's what you're seeing here in front of you. So the probability of being at certain storage levels based on the 1,000 projections is shown there in the upper left, or the probability in the lower right there for having certain amounts of average annual spill. And then you also have the probability of average annual groundwater pumping. So you could see that with the range of projections that we're working with, there's a wide range of plausible reservoir system metrics in the future that we can plan for. And that's the power of this, because there's no reason to think that the next century will be anything like the previous century, especially when you consider natural variability and climate change. And we're planning for all of them. Next slide. Okay, so future opportunities. Yeah, thank you, Steve. So we have wet years getting wetter, but most years getting slightly drier. So we got to be thinking not just about drier futures. We got to be thinking about how to capitalize on the wet years to get through potentially deeper droughts. And that's really what the rest of these opportunities rely on, is this concept that in the future, we're still going to get wet years. They could be wetter. And then we're going to have dry years, of course, and they're likely going to be a little drier because it's going to be hotter. So we got to figure out how to capitalize off the wet to get through the dry. And before I go into that, it's important to consider the broad Phoenix area water supply and the water supply portfolio. In blue here in the central part of the valley, a lot of those areas have their water supply from SRP, from Colorado River, and from groundwater. And then if you go to the outside of SRP service territory in blue, the yellow, these are areas that have Colorado River water through the CAP canal and groundwater. And then if you go in the very far outskirts of the valley, these are areas that are basically entirely groundwater dependent. So you can imagine that the definition of drought in these 3 areas varies. where when you have three water supplies with maybe drought not occurring at the same times, or the reservoir system responding differently, Colorado River versus Salt and Verde, drought means something different than if you're in CAP only territory. And then, of course, if you don't have any surface water supply, you only have groundwater, then your definition of drought is much more related to the ability to have a balanced aquifer or something like that. So it's it's a challenge in the Phoenix area that there's this diversity of water supply portfolio, and the projects that I'm going to talk about can address some of this. So next slide. So we're going to talk about three projects. I'll talk about two, and Steve will talk about one. And I believe the first one is what Steve will take, and that's operational flexibility in Roosevelt Dam flood control space. So that's up there on the right-hand side of the slide there. And then there's project number two, Bartlett Dam modification project. And then there's the SRP CAP interconnect facility. And these are basically broadly going to be new water supplies that can be delivered outside of SRP service territory. And that's the key. All right. Thanks for the note there on the misspelling. All right, next slide. Go ahead, Steve.
All right. So the first of the three projects that Bo mentioned was the Roosevelt, the operational flexibility and Roosevelt Dam flood control space. So I mentioned briefly at the beginning that Roosevelt Dam in the mid-90s was modified and raised following the Safety of Dams Act. It was raised to add a small portion of new conservation space that Plant 6 cities have water too, but that's included in that conservation space you see there. But most of that heightening was to add flood control space and safety of dam space. And so that flood control space is about 24 feet and it can hold about a little over 500,000 acre feet of water in that 24 feet. And then you can see that it's even more in the rest of the safety of dam space that was heightened. Basically, in flood control space and safety of dams, there's basically if that filled, that would be double the size of the conservation storage of Roosevelt. So the flood control space is operated by the U.S. Army Corps of Engineers flood control manual. So there's a water control manual that dictates when releases, and it's designed to basically manage floodwaters. So once we reach the top of conservation and water enters that flood control space above conservation space, it will be then dictated by the water control manual. So right now, the water control manual is developed in 1996, 97, basically dictates how much water can be released. And it's designed basically to minimize during an event, because typically if water is increasing into flood control space, water is also filling the Verde, and we're spilling from the Verde probably large amounts. So basically to minimize the amount of spill from the salt during that, and once the peak flows from the Verde pass, then flows can be increased to evacuate that flood control space. And right now that's designed to be evacuated within 20-day period. So once it enters that flood control space, water needs to be evacuated basically within 20 periods. And so the higher it gets in flood control spaces, the higher those releases would get out of Roosevelt and through the salt system. This past year, we reached about 4 feet, and that was the highest it's ever been in flood control space. Prior to that, in 2010, 2009 and 10, it rose about a foot into flood control space. This year, it was the highest it's been, which is only 4 feet of that 24 feet of flood control space. And initially, releases were only 2,000 and got up to about 10,000 later after the storm had passed, but evacuated within that 20-day period. So right now, the flexibility that basically the planned deviation that's being submitted and proposed to the Army Corps of Engineers, and right now it's gone through its feasibility, it's gone through its environmental permitting, NEPA, all right now. So we're basically looking to get approval to start implementing that. Basically, over a 5-year period as temporary planned deviation, where we could potentially store that at least in the bottom 5 feet of that flood control space, um, which is about 100,000 acre feet of total storage, and extend that period that it can remain in the flood control. So it extend it from having to evacuate in 20 days to having it to extend in 120 days. And what that would do, that would allow that water to potentially, in that first 5 feet, that 100,000 acre feet additional water, to be put to use um, throughout the spring and early summer and into the summer when demands are higher and flows have passed. In that 20-day period, typically, reservoirs are spilling and there's not need, so that water gets spilled. But this would allow it to maintain that first 5 feet. Above that 5 feet, it would still get passed out in that 20-day period, according to the water control manual. But this would allow additional water source by storing that longer period, that 120-day period, in flood control space. And that could be delivered to SRP customers as well as off project. This would be a source of water that could be delivered off project as well to some of those areas that may not be served directly by SRP service area and in the CAP area. And we'll talk a little bit about how that flexibility might happen with the exchange at the Granite Reef between CAP and SRP. So I'll hand it off to Bo to talk about the other two.
Sure. Thanks, Steve. Yeah, so this the water deliveries that Steve was just talking about, a lot of that purple on that previous slide there, where that water can be delivered, is in the areas that are outside of SRP territory, but have CAP and groundwater. This next project can potentially expand further than that. So this is the modified Bartlett Dam project. We're in a feasibility study with the U.S. Bureau of Reclamation. And basically it's the motivation was Horseshoe Reservoir filled up with so much sediment since the mid 20th century when it was constructed that there was a loss of capacity, a loss of water storage for our customers. And how to address that? Do you dig up that sediment and pile it up next to Horseshoe Reservoir? Or do you dig up that sediment and truck it out? Or do you raise Bartlett Dam downstream a little bit to get that lost capacity back? Or you might as well raise it a lot if you're going to do that and have more storage to get a new water supply by capturing more floodwaters. So really, this one's more simple. It was found that it's way more feasible. Cost-benefit analysis is more in favor of raising Bartlett Dam rather than those other alternatives. So a bigger reservoir captures more floodwaters during the wet winters, and that's a new water supply. So next slide. So we're going to get those wet winters in the future. Those aren't going away, and they could be wetter. So having a much larger dam in place, the proposal is to have all of Horseshoe's conservation storage in Bartlett Dam, and there would actually be over 300,000 acre feet of new space on the Verde system, even after the capacity loss in Horseshoe is restored in Bartlett. So that's a big chunk of water. And this last winter, it would have filled up all the way. So it happens. And so Steve talked about the previous project, about 100,000 acre feet of extra water can happen during wet years. This new water supply is over 300,000 acre feet. And it's a little more simple than what Steve was talking about. It's just a bigger reservoir, can capture more floodwaters, and we can deliver it. You can store it for conservation. Next slide. So this next slide is going to show the federal partners on the project, and there's a lot of them, I believe 20 to 30, and they span the whole Phoenix area. And there's partners out in Buckeye and Queen Creek and Pinal County, areas that are entirely groundwater dependent. And these people are a part of the project because they could potentially get a portion of this new water supply. So this is showing that these extra surface water sources that are generated on the Salt and the Verde rivers can be put to use outside of the SRP service territory in areas that are totally groundwater dependent potentially. The details need to be ironed out, but that's in play right now. Next slide. And I believe this will be the last project. where Steve and I talked about extra water being able to be delivered off project outside of SRP service territory. We can do a lot of that with water swaps on paper right now between the Colorado River water source, this through the CAP canal. But being able to physically put water into the CAP canal is key. So if we can physically put water from a modified Bartlett or water from improved operations in Roosevelt flood control space into the CAP canal, then that adds an added layer of flexibility to deliver off project and move these new water sources, which is really important. We can get the water to water treatment plants out there in Pinal County potentially. Whereas right now we physically can't do that. There's only one direction. So go ahead, next slide, Steve. All this is happening right at Granite Reef, where for quite some time there's been the ability for Colorado River water to go into SRP's canal, but the reverse has not been able to happen. So another one of our planned projects is to have what's called the SCIF, the Salt River Project CAP interconnect facility, which gives us the ability to go from SRP's water supply into CAP to improve regional water supply resiliency with those new water resources. And then this is a zooming in at Granite Reef Diversion Dam. You can see the Arizona Canal and the South Canal. Those are SRP canals. Conveniently, the CAP canal goes right between those, right through this area. And we can, with this new infrastructure, we would be able to put water into CAP's canal going off towards Pinal County. Next slide.
So I think, yeah, we can wrap it up with just summarizing the great winter we had last year and where we're at this year. But you see a picture of Bo in the snow?
Not yet. It's coming probably.
There.
All right. So yeah, last year we had an incredibly wet winter. It was actually very snow dominated. We had the deepest snowpack on the Verde since 1973 on April 1st. It was incredible. The snowpack you see there where the helicopter is, there was actually in that area, there was as much water locked up as ice in the snowpack on April 1st than rainfall in that area over the last 3 monsoon seasons. So it was amazing. We had a lot of flow in the rivers and a lot of spill from the reservoirs. Next slide. And it was the most snow-dominated water year since 1973. There was so much snow on the Verde River watershed that we ended up having very little flow into March relative to how much snow was still up there on the Verde watershed waiting to come down. And that really had never happened before. This goes back to 1982. We probably only had this situation happen in 1973. So you can see 2023 there. And Steve, I'll go ahead and have you transition now so we don't wait. 2023 there is unlike any other year that we've seen recently, and how much snow was left on the watershed relative to how much flow had it come down the Verde. So with that, we actually started releasing floodwaters, even though there wasn't a flood yet, in early March last year. We released with 60,000 acre feet of available space in the Verde in March 2nd, which is something we've never really done before because there was so much snow on the watershed backing us up. So it was quite fascinating. Then we had 2 rain events in late March, and that allowed us, all that extra space allowed us to really shave the peak of the hydrograph. So 68,000 cubic feet per second into Horseshoe was the highest inflow since 1995. And we only released 37,000 out of Bartlett. That snowpack really helped out last year. And with that end of that wet winter, we were at the highest storage ever on the reservoirs. And putting the 2 infrastructure projects in place together that Steve and I talked about, there would have been 400,000 acre feet or more of new water in central Arizona from last winter alone. Next slide. I believe Steve's going to finish us off with the current winter we're dealing with right now.
Yeah, and so just to summarize where we're at now, last year we showed that we were well above average for snowpack, especially on the Verde. Um, so not quite as high on the Verde as last year. Last year, 277%, but this year it's still well above. It's 167 with this last storm we had in early February. But you can see the salt's almost as about the same as it was, just slightly less, but still above average at 126% of the snowpack. So this last storm really set us up as far as getting a good snowpack across the watershed, brought us up to about normal precipitation. We had a drier fall. We had a much wetter fall last year going into the winter, so we saw a much more productive runoff in January. We didn't see that this year, but we are starting to see more runoff. So we do expect the snowpack to be more efficient with runoff when we see in February, March. And if we get some more storms, we could potentially fill these reservoirs again. Right now, with the snowpack that's up there, it can, if it melts off, we can get close. But if we get a couple late February or March storms, we had one of the wettest Marches last year, but even if we get, above normal March, we could see those reservoirs fills, and that could then take advantage of those projects like the Roosevelt. Right now, we're projecting it to come close to filling Roosevelt based on the current conditions and forecasts. But if we do get wetter conditions, we could potentially get Roosevelt to go and reach into FCS again this winter, as like it did last year, and take advantage of that opportunity. So that's where our reservoirs are. Despite all this, we're still at 83% on the SRP reservoirs. So good conditions. So we'll kind of stop there. And we talked a little bit about the Colorado River salt versus the Salt and Verde, the groundwater, about the drought and warmer temperatures impact on especially the Salt and Verde, and this need for capitalizing on these wet years with some of these projects that we talked about to be able to store that water to get through those drier stretches. So I'll open that up and throw it back to Jake and any questions we have.
All right, thanks a lot, guys. Lots of great information there. It's nice to know where we stand currently as well. So a couple questions that have come in. Question is if the copy of the presentation can be made available to those that are participating today. If so, I can make that, distribute that to those who are interested. Oh, Steve, is that all right? Would we be able to share that? Okay.
Yeah.
In Al's fields, asking in the 50s, cloud salting was popular to help with rain, or is any of that being done? And then is there any comment on chemtrails?
The cloud seeding is something that we are looking into, but it's a slow process. But there's been a study with the Desert Research Institute at the University of Nevada, to a modeling study to determine how feasible it would be, and the first steps to how efficient it would be to cloud seed in the White Mountains in eastern Arizona. And that would require a lot of great cooperation with White Mountain Apache tribe, because those cloud seeding generators would likely be ground-based and on their lands. And they're all for cooperating with us. And right now we had an initial modeling study that was completed with Desert Research Institute, but there's many more steps that need to be taken. But we're absolutely considering that, because that could be something that we need to capitalize on as well. And then chemtrails, I don't have any comments on chemtrails.
Okay. Kimi was asking regarding when you were talking about climate change and natural variability of the 1,000 potential future water years, how do those compare to current design storms?
Yeah, that's a good question. So everything that I've been talking about is much more water supply focused. Those climate change adjustments are more of a monthly volume type of scenario, as opposed to a hourly or daily viewpoint, which is what a flood routing situation would demand. So these the projections I talked about have really, really wet winters in it, but there's not the detail that goes into determining how individual floods change. And honestly, that requires a lot more study. And I think that it's so challenging. You might expect a lot of the people in the hydrologic community to think that you need to go ahead and adjust all the design storms and the probable maximum floods for climate change. But from my experience, that's really not being done yet because it's so challenging, and it's actually quite unknown exactly how climate change will impact floods in the future.
Awesome. And then we got just a couple more. Any forecasts on what will happen with Meade, so on the Colorado, given the recent storms?
Steve, have you looked at a recent CBRFC forecast from that? I haven't
I
looked in
haven't
a
looked
couple
at
of days.
their forecast. Yeah, I don't know
Okay.
how the Colorado reservoir or watershed is I think now above median, but again,
Yeah,
it's not going to refill from what one wet winter. You know, it might give some relief, you know, not drop into, you know, lower tiers, you know, shortages, stay in the tier one shortage, or potentially help it a little bit. But again,
yeah,
Yeah.
I think the snowpack is probably in better shape than the streamflow forecast because of um, dry antecedent conditions. So I think the streamflow forecast has come up a bit from the recent storms, but we still need more snow to develop on that Colorado River watershed to get another wet winter.
Yeah, and Al, if you want to, get the most current forecast on that, you can refer to like the Colorado Basin River Forecasting Center. Their website has a lot of that stuff regarding the Colorado River. So you can check that out. Uh, is SRP capitalizing on any recycling used water? And if so, what's your involvement in that?
Steve, you want that one?
um, well, we operate, for example, not necessarily directly. I mean, we are a raw water provider to the cities. We provide water to cities and agricultural, that what's left of it throughout the valley, in the service area. But we do operate, say, groundwater recharge facilities, Granite Reef underground storage, and so cities will take surface water supplies or others. But for example, the city of Mesa has effluent, that they let recharge into the ground for recharge groundwater credits. But I don't know of anything direct recycling of recharge water that to do, but it would be something cooperative through, say, the cities, um, such as the groundwater effluent or the effluent that's recharged through SRP's groundwater recharge facilities.
Okay, great. Well, that's it for the questions. A lot of appreciation being included there for your time and the presentation. Thanks again, Bo, Stephen, for putting this together. Appreciate you sharing the work that you guys do on a day-to-day basis. It's important for the valley, obviously, and it's nice to see that the Salt River is able to navigate some of these droughts that we've seen and that we anticipate in the future. So appreciate the work that you guys do. Couple of things just before we wrap up, just reminders. Again, if you are looking for CFM credits, please put your name in the chat box, and so we can get a timestamp of when you left the meeting. And just a couple of sneak peeks for the upcoming in March. We have Dennis Richards going to talk to us. He's a longtime hydraulics and scour engineer. He wants to share some of his recent research with us. And then in April, we're going to be hearing from Bruce Hallen with the Arizona Department of Water Resources. So we look forward to that. Keep an eye out for those announcements. They'll be coming through your emails and through the ASC Collaborate platform as well. So appreciate everybody's time this morning. And with that, hope everybody has a great day.
Thank you. Bye,
Thank you.
everybody.
Good day.